have discussed the derivatives part of the continuity and differentiability, and in this first topic of derivatives we have discussed. Okay, and here what is a derivative and how it exists, that all we discuss. Suppose f is a real valued function and c is a point in its domain, then derivative will be, this is the equation, limit h tends to 0 f of c plus h minus f of c by h, and the derivative of f at c is denoted by f dash of c or d by dx of f of x, and f dash of x is limit h tends to 0 f of x plus h minus f of x by h. We can denote the derivative f by f dash of x or d by dx of f of x, and if y is f of x, then we will denote by dy by dx or y dash. Process of finding a derivative of a function is called a differentiation, and this you already studied in the last year, that is u plus v the whole dash, u dash plus v dash, uv the whole dash, that is the product rule. First derivative into second plus first into second derivative. Then u by b the whole dash is first derivative of numerator into denominator minus numerator into derivative of denominator by derivative square. Then how the differentiation will work? We have to take left hand derivative and right hand derivative. This is the equation of left hand derivative, children. F of a minus h minus f of a by minus h. This is the equation of right hand derivative, limit h tends to 0 f of a plus h minus f of a by h. Then this is the theorem 3. If f is differentiable, then it is also continuous. But if all the continuous function need not to be differentiable function, children. But if it is differentiable, then anyways it will be continuous. Chain rule. This is the chain rule, children. But when we do the problem now, you will understand it clearly. These are some of the formulas. Okay. X raised to n is n x raised to n minus 1, x is 1, constant is 0, sin x is cos x is minus sin x, derivative of tan x is sec square x, sec x is sec x tan x, cot x is minus cosec square x, cosec x is minus cosec x cot x, and sin inverse x, that all we studied in later, and e raised to x is e raised to x, log mod x is 1 by x, a raised to x is a raised to x log a. That much you studied this time. Okay. Then whenever the others coming now, that I will explain in that time. Okay. This is the left hand derivative formula. This is the right hand derivative formula. Now, this is very important because all the year one question is there, like check the differentiability. So f of x is modulus of x minus 1 plus modulus of x minus 2. Then here first, always what we are doing, we will check what are the values of x. So here x minus 1 equal to 0 now, so x is equal to 1. Here x minus 2 equal to 0 now, so x is equal to 2. So we set the limit 1, 2. So x is less than 1. Then 1 less than or equal to x less than 2. X is greater than or equal to 2. Already you know now. Only one thing I will explain here. X is less than 1 means I am taking 0. 0 is less than 1 now. 0 minus 1, that is minus 1. So this function is negative. 0 minus 2, minus 2. So this is also negative. You check the sign of that one. 0 minus 1, minus. So minus. 0 minus 2, minus 2. So minus. So both functions are negative. So how I will write? Minus of x minus 1 minus of x minus 2. That is minus x plus 1 minus x plus 2. Minus 2x plus 3. That we got the first function. Okay. One more thing I will clear. Second case also I will explain to you. So I will between 1 less than or x less than 2. That I will take 1.5. So 1.5 minus 1, 0.5. So this is positive. So x minus 1. 1.5 minus 2, minus 0.5. So this is negative. So x minus 2. You check the sign, okay children? 1 minus x plus 2. X cancel, 2 minus 1, 1. I hope this is clear. Okay. Then at x is equal to 1, you have to check LHD, f of a minus h minus f of a by minus h. Here 1 na, so 1 minus h minus f of 1 by minus h. F of 1 minus h, what is our function? Minus 2x plus 3. So minus 2 into 1 minus h plus 3. Then f of 1 here. So that is 1. So minus 2 into 1 minus h plus 3 minus 1. 3 minus 1, 2 na. Minus 2 into minus h plus 2h. 2 cancel. So 2h by minus h. H cancel. So you will get minus 2. RHD. Limit h tends to 0. F of a plus h minus f of a by h. F of a plus h. So here 1 plus h. 1 plus h minus f of 1 by h. So 1 plus h. That is 1 now. And at 1 also it is 1. So 1 minus 1 by h. See, 0 by h, that is 0. So LHD is not equal to RHD. So the function is not differentiable at x is equal to 1. Similarly, you can do at x is equal to 2. Now the second exercise is the normal differentiation. That is actually it is a recap of the last year. Okay. So sine of x square plus 5. How you will do sine? Derivative is here chain rule is there. Sine is cos. So I will write the function cos of the argument value that is x square plus 5. Then x square plus 5 you have to take the derivative. That is x square is 2x, 5 is 0. So 2x into cos of x square plus 5. Next is cos of sin x. First is the cos function. Cos derivative is minus sin x. Angle is sin x. So minus sine of sin x. Then sin x derivative is cos x. So minus cos x sine of sin x. Then sine of ax plus b by cos of cx plus d. Here fraction. That means quotient rule. How the quotient rule will work? Numerator derivative, that is sin ax plus b will be cos ax plus b, and the derivative of ax plus b is a, into the denominator cos cx plus d, then minus numerator sin ax plus b into derivative of the denominator cos, that is minus cx plus d, into c, divided by the denominator square. Then by simplification you will get this answer. Now next is cos x cube into sin square x raised to 5. Here product rule and chain rule. So first is this function, second is this function. So first derivative cos x cube, that is minus sin x cube. Then x cube will be what? 3x square into the second function plus cos x cube into sin square. So square is there first, that is 2 sin x raised to 5. Then sine, that is cos x raised to 5. Then x raised to 5, that is 5x raised to 4. Okay. By simplification, you will get the final answer. Next. 2 root cot x square. So first is 2 into root x. Root x derivative is 1 by 2 root x. So 1 by 2 root cot x square. And cot is minus cosec square x square. Then x square will be 2x. Okay, then cot 2 cancel. Cot x square I can write it as cos by sine. Cosec square I can write it as minus 1 by sine square into 2x. Then by the arrangement or simplification you will get the final answer. Then the last question. Prove that the greatest integer function defined is not differentiable at x is equal to 1, x is equal to 2. Children, you already know this is not continuous, so it is not differentiable, but we are checking that one. So at x is equal to 1, what is our LHD? Limit h tends to 0, f of at 1 na, so 1 minus h minus f of 1 by h. 1 minus h, 1 minus h, if it is 0.99, what is our answer, children? It will be 0 na. So 0 minus f of 1 will be 1 by h, that is minus 1 by h, it is not defined. H I substitute as 0, so minus 1 by 0 not defined. Then f of 1 plus h minus f of 1 by h is the RHD. 1 plus h, 1.99, 1.22, 1 plus h. So after h, after 1. So 1.22, it will be 1 only. And integer, square integer 1 also, it will be 1 only. So 1 minus 1, 0 by h. So LHD is not equal to RHD. So the function is not differentiable at x is equal to 1. Now I will take the 2. At 2 also we have now. So 2 minus h. F of 2 minus h minus f of 2 by h. 2 minus h. 2 minus h. That is 1.99. So answer will be 1 now. 1 minus f of 2 will be 2 by h. So you will get same minus 1 by h. HI substitute as 0. So you will get minus 1 by 0 not defined. Now f of this one. So this will be f of 2 plus h minus f of 2 divided by h. 2 plus h like 2.1. 2.2 our answer will be what? 2. And f of 2 also 2. So 2 minus 2 by h it is 0 by h, that is 0. Here also LHD is not equal to RHD. So the function is not differentiable. Children, I hope this is clear. This is the first part of derivatives. Okay. So if you have this, you should be clear, because every time you are using chain rule, product rule, it will come in the every exercises. So please study this one. Please go through the video. If any doubt is there, please ask me. Okay, children. Thank you.